Okay guys, so you just finished up your test on chapter 9, yay! And we're moving on to chapter 10, and I'm not in class today, but you still have homework. And so the sub should have given you notes before you left class. If not, I did post a copy online, okay? So you want to have those handy. And it's notes for section 10.1. And today's really actually going to feel a lot like geometry. So hopefully you like geometry, and I think you're going to make Mr. Adams and Ms. Geiger proud by recalling what you know. I am going to review it, but I hope you remember some of this stuff. So you worked on the distance formula in geometry. The distance formula is D equals the square root of x sub 2 minus x sub 1 in parentheses squared plus y sub 2 minus y sub 1 quantity squared, okay? And this is something that you have to know the formula, but one way you can kind of remember it, this formula actually comes from the Pythagorean theorem. So a squared plus b squared equals c squared. So, but they just took the square root of both sides. So if I did that, the x2 minus x1 is like your a, and that y2 minus y1 is like your b. So that could maybe help you remember that there's always a plus in the middle here. In the parentheses, though, we do have minus, okay? All right, so how are we going to use this distance formula? So we're going to keep it handy. How do we use it? It says find the distance between the points -2, 5, and 3, 1. All right, so the first thing I do is I label each point. I'm going to label this one x1, y1, this one x2, y2. We did this when we did slope, and I'm going to plug those points directly into the formula. I'm going to change colors. So D equals the square root of. All right, we want to do x2 minus x1. It really doesn't matter which order you use unless, except that you have to use, if you use this as x1, then this has to be your y1. If you use this as x1, this has to be your y1. So we're going to do -2 minus 3 squared plus 5 minus 1 squared. So you can see they're kind of interchangeable. You can flip them around. And let's go through that process here. So we've got -2 minus 3, which is going to give me 5, so 5 squared, plus 5 minus 1, which is 4, so I'm going to get 4 squared. The one thing I do want to point out right here is that you always need to treat the square root like parentheses and follow those order of operations. So you have to do everything under the square root first. You can't take the square root of each piece and then add them together. So remember, square root is like parentheses. So here what we would do is we take 25 plus 16. We add them together and we're going to get root 61. And so the distance between the points is root 61. All right, well, where is that? You really do need to think about this for a second. Now, when you think back when we talked about square roots at the beginning of the year, what two numbers is this between? Well, the square root of 49 is 7, and the square root of 64 is 8. So this is somewhere between 7 and 8. Okay, so it's approximately between 7 and 8. And you could use your calculator. If you put this into your calculator, which you can go ahead and do, you're going to get about 7.81. Okay? So that's the distance between these points in the coordinate plane. All right, why are we even doing this? Well, you're going to use that. You're going to use the distance formula to tell if a triangle is either scalene, isosceles, or equilateral. So let's talk about that for a second. Let's review from geometry these types of triangles. A scalene triangle has no equal sides. No equal sides. An isosceles triangle has 2 equal sides, and an equilateral triangle has all equal sides. Okay, so here's an example. We're going to classify the triangle as either scalene, isosceles, or equilateral. Okay, you guys actually have one on yours, and I forgot to draw mine in. But we have a triangle at the point 1, 3 is A. So I apologize. Is C. And 4, 1, 2, 3, 4. And 4, 6 is A. And 6, 1. So somewhere over here. 6, 1. All right, so how are we going to tell if they're scalene, isosceles, or equilateral? Well, if it's a triangle, you're actually going to use the distance formula to find the distance between each set of points. So you're going to have to do the distance formula 3 times and see if any of the sides are equal. All right, so I'm going to do the distance formula for, I'm going to say AB first. All right, so again, it's the square root of I subtract my x's, square them, subtract my y's, and square them. So 6 minus 4 squared plus 1 minus 6 squared, okay? So 6 minus 4 is 2, 2 squared is 4. So I get the square root of 4 plus 1 minus 6 is 5, 5 squared is 25. So I get that that distance is root 29. Don't have to do anything more, can leave it like that. All right, now we're gonna do the distance. How about between B and C? Okay, so I'm just gonna write it like that so we know what we're doing. Distance between B and C. Again, we're gonna subtract our x's. So 6 minus 1 squared plus 1 minus 3 squared. All right, 6 minus 1 is 5, 5 squared is 25. 1 minus 3 is 2, 2 squared is 4. And so I get, oh, look at that, root 29. So now I have 2 sides, AB and BC are actually equal. So this could be, it's not scalene at this point, but we still have to do the last one because it could be equilateral. At minimum right now it's isosceles. All right, so now we're gonna do our last one, which would be our distance AC. I'm gonna change pens. And that would be the square root again. Subtract your x's. So 4 minus 1 squared plus 6 minus 3 squared. 4 minus 1 is 3, 3 squared is 9. 6 minus 3 is 3, 3 squared is 9. Okay, and I get the square root of 18. Square root of 18 is not equal to 29 and 29. So it is not equilateral, and my triangle is isosceles. Okay, so tomorrow in class we're going to be practicing that. And yeah, it just gets a little tedious, but it's kind of neat to see that you can actually mathematically prove the type of triangle that you have. Okay? All right, so let's move on. Next page. Another cool geometry formula is the midpoint formula. And this can help you to find the midpoint of a segment in the coordinate plane. In the coordinate plane. Okay, so the midpoint formula, just to recall it for you, you're trying to find a coordinate, okay? It's a coordinate. So you're going to be finding an x, y coordinate. So to find your x, you take x1 plus x2 and you divide it by 2. I actually just always say it's the average of the x's, because that's what that means. And that'll give you your x coordinate. To find the y coordinate, you're going to do y1 plus y2 over 2. And I always just say that that's the average of the y's, and that will give you the y coordinate. Okay, so let's practice. How do we do that? How to use the midpoint formula. To find the midpoint of the line segment joining -7, 1 and 2, -2, 5, again, if you want to, go ahead and label them x1, y1, x2, y2. All right, so if I want to find the x's, I'm going to do -7 plus -2 all over 2. That's going to give me my x coordinate. And then for my y coordinate, I'm going to do 1 plus 5 over 2. 1 plus 5 over 2 is 6 over 2, which is 3. -7 plus -2 is -9 over 2. You can also write that as, or -3.5. So I know that this coordinate is the midpoint of that segment, okay? Good? All right. All right, so now we're going to put it all together. How are we going to put it all together? Well, first we need to kind of think. What does the word perpendicular bisector mean to you? and I don't want to, I don't want to hear it. I can kind of hear you guys in the back of my mind saying, it means nothing to me, Mrs. Frederick. It should mean something. Perpendicular means that it creates a 90-degree angle, and hopefully that bisector means cut in half, okay? All right, so we can use the midpoint formula and the distance formula to write a line equation of the perpendicular bisector, but we need to remember a couple of things. To write an equation of a line, you need a minimum of a coordinate point and slope, okay? A coordinate point and the slope. All right, so then you can use either the point slope equation or the slope intercept equation to write an equation of a line. So let's review these. The point slope equation is y minus y1 equals mx minus x1. You plug the coordinate you have and the sloping you have into this equation and you leave it. Some of you actually prefer to use the slope intercept equation, which is y equals mx plus b. Okay? Let me show you how it works. So you want to write an equation for a perpendicular bisector of the line segment joining the point -1, 4, and 5, 2. So I've got this point, -1, 1, 2, 3, 4, -1, 4, and it's point A. And B, I've got 1, 2, 3, 4, 5, 2. Now you don't have to actually draw it, but I just want you to see it. So this is the segment. But I'm not writing a line equation for that segment. I want to write an equation for the perpendicular bisector of that segment. So I have some line going through it like this. It's perpendicular. This is the perpendicular bisector. Okay? But I'm going to have to use this segment to get the minimum I need. I need that point and that slope. Okay, so if I want to use the perpendicular bisector, the first thing I can do is I can find the point. Well, this point right here is on the perpendicular bisector, and that point right there is the midpoint. So I'm going to find the midpoint of this segment, AB, okay? So I find the midpoint using the midpoint formula, so I'm going to do 5 plus -1 all over 2. That's going to give me my x coordinate, and I'm going to do 2 plus 4 over 2. That's going to give me my y coordinate. So 5 plus -1 means 5 minus 1, which is 4, over 2 is 2. And 2 plus 4 is 6. 6 divided by 2 is 3. Okay? All right, so that's my point. I've got my point, now I still need my slope. Now let's talk about this. If I know this slope, and this slope is perpendicular to it, I can just use the negative reciprocal slope of my segment. So I'm going to find the slope of my segment by using my slope formula, y2 minus y1 over x2 minus x1. So let me do that. So I'm going to do, let's see, 4 minus 2 all over -1 minus 5. 4 minus 2 is 2. -1 minus 5 is -6. So I have a -1/3 as the slope of this of AB. But I want the perpendicular slope. So what am I going to do? I'm going to take the negative reciprocal. So my slope is going to actually be 3. All right, so now I have my points. I have my slope. I'm going to go back to that equation, point slope equation. I'm going to plug in my values. Y minus y1, which would be my 3, equals m3 times x minus 2. Okay? All right, so now I want you to try. Last thing. You are going to take the time and write an equation of the perpendicular bisector of the line joining -2, 1 and 1, 4. So I want you to do this, bring it into class tomorrow, and we'll review it, okay? So I'll see you guys tomorrow. Have a great night.